Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Yang berbahagia Profesor Emeritus Dato Dr. Haji Kamel Ariffin Muhammad Atan, Presiden Aismm, yang berusaha Profesor Dr. Noakmal Ibrahim, Setiausaha Aism, penceramah kita pada hari ini. Alhamdulillah, bersyukur kita kehadrat ilahi kerana dengan izinnya dapat kita berkumpul dalam majlis ilmu hari ini di akhir bulan Januari 2024. So, ceramah perdana bulanan ASM adalah satu sesi perkongsian dan perbincangan ilmuwan mengenai perkembangan pembangunan dan juga isu-isu semasa berkaitan dengan sains matematik di Malaysia maupun di luar negara. Untuk tahun 2024 ini sebagai permulaan, Aism dengan berbesar hati menjemput Profesor Dr. Muhammad Rezal Dato Kamel Ariffin untuk membuka tirai 2024. Jadi sebelum majlis dimulakan, saya dengan ini menjemput Profesor Dr. Noakmal Ibrahim untuk memfungsikan sesi ini dan juga untuk memperkenalkan penceramah kita pada hari ini. Dipersilakan, Prof.
Okey, terima kasih Puan Zurita. Assalamualaikum warahmatullahi wabarakatuh. Apa khabar semua? Alright. Okey, bismillahirrahmanirrahim. Seperti yang telah dinyatakan oleh Puan Zurita, ini adalah pembentangan yang pertama untuk tahun ini. Jadi pembentang kita ialah atau penceramah kita ialah Profesor Dr. Muhammad Rezal, Datuk Kamel Ariffin. Jadi sebelum saya mempersilakan beliau untuk membentangkan ceramah beliau, jadi saya bacakan sedikit sebanyak latar belakang beliau. Jadi Profesor Dr. Muhammad Rezal telah menerima ijazah Bachelor Science pada tahun 1999 dan Master Science pada tahun 2002 dalam bidang matematik daripada Universiti Putra Malaysia. Dan beliau telah dianugerahkan ijazah PhD pada tahun 2009 yang dikurniakan oleh Universiti Kebangsaan Malaysia juga dalam bidang matematik. Dan buat pada masa ini beliau bertugas sebagai profesor di Jabatan Matematik dan Statistik Fakulti Sains Universiti Putra Malaysia. Beliau pernah menjawat jawatan sebagai pengarah INSPAM iaitu Institut Pendidikan Matematik UPM pada tahun 2020 sehingga 2023. Dan seramai 7 orang pelajar PhD dan 8 Master Science dalam bidang kriptografi bermatematik telah bergraduat di bawah penyeliaan beliau. Buat masa ini, beliau sedang menyelia 6 pelajar PhD dalam bidang kriptografi bermatematik. Dan beliau telah menerbitkan lebih daripada 140 pelbagai dokumen saintifik termasuk jurnal, makalah dalam jurnal antarabangsa, conference, buku, bab dalam buku, patent dan juga polisi. Dan pada tahun 2007, beliau telah mempelopori penubuhan Malaysian Society of Cryptography Research, iaitu MSCR singkatannya. Dan beliau merupakan Presiden MSCR sejak Disember 2020. Pendidikan beliau dalam bidang kriptografi adalah lebih kepada mereka bentuk dan menganalisis number theoretic based crystal systems dan post quantum cryptography. Dan kumpulan pendidikan beliau sekarang ini ialah dalam usaha untuk mendapatkan kaedah yang lebih baik untuk mengurangkan kompleksiti masalah RSA. Beliau juga telah dijemput sebagai salah seorang panel of experts untuk Second Oxford Post Quantum Cryptography Summit pada tahun 2023 yang telah diadakan di Institute Mathematics University of Oxford UK September tahun lepas. Selain daripada kriptografi bermatematik, beliau juga berminat dalam sistem dinamik kalut. Jadi tanpa melengahkan masa, dengan besar hati saya mempersilakan Profesor Dr. Muhammad Rezal Datuk Kamel Ariffin untuk membentangkan ceramah beliau yang bertajuk Mathematics in Mainstream Nation Building Revisited. Silakan, Prof.
Baik. Terima kasih Profesor Kumar. Assalamualaikum warahmatullahi wabarakatuh. Puan Zurita jelas
Jelas, Prof.
Okay.
Jelas, Prof.
Baik. Terima kasih kepada pihak penganjur kerana menjemput saya untuk memberikan ataupun berkongsi sedikit pengalaman dan untuk kita lihat bagaimana bidang yang kita minat ini, iaitu matematik, bagaimana kita boleh terlibat bersama dalam usaha membangunkan negara kita yang tercinta ni. Jadi saya mulakan dengan share slide saya. Okey, nampak
Ya, nampak.
Alright, okay. So, baik. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh sekali lagi. Slide ni dua bahasa. Kebanyakannya dalam bahasa Inggeris. Jika perlu saya akan berbahasa Inggeris. Jika tidak perlu, bagi mereka yang tidak boleh berbahasa Melayu, dia boleh rujuk saja teruslah daripada slide. Ya. Okay, so tajuknya Mathematics in Mainstream Nation Building. Jadi pertamanya kita kena faham apakah itu nation building, membangunkan negara. It is the basis on which to ensure that the country takes up an effective role within the world community. Iaitu sekiranya kita terlibat dalam pembangunan negara, ini adalah untuk memastikan negara kita ada peranan yang berkesan dalam dalam masyarakat dunia. Ya. Sebab dunia sekarang dikenali sebagai global village. Jadi kita interconnected, memang saling berkait. Maka kita perlulah melibatkan diri dalam usaha ini. Kita tidak boleh lagi hanya duduk dalam kepompong kita. Dan each citizen has a role to galvanize resources and increase productivity to ensure the success of the tanah air. And each citizen has a patriotic duty to fit himself into the big puzzle of nation building. Jadi telah berlalu zaman apabila kita masuk ke dalam proses bermasyarakat selepas habis kita punya pengajian untuk kita dipilih dan diletakkan pada satu-satu tempat. Kini kita sebenarnya bertanggungjawab untuk meletakkan diri kita dalam di mana posisi yang sesuai untuk diri kita. Dan telah berakhir zaman orang akan mencari. Kalau kita masih duduk dalam kepompong menunggu orang mencari kita, seolah-olah macam kita di sekolah, tunggu cikgu lantik siapa jadi pengawas dan sebagainya. So bukan begitu. So you have to fit yourself into the big puzzle. Baik, ini adalah sebenarnya prolog ni adalah saya punya abstract dan mungkin ramai yang dah baca. Saya baca semula. So the modern computer, which could be traced back to the algebraic and logic works by Alan Turing, in his article on computable numbers in the Proceedings of the London Mathematical Society on May 28, 1936, was the catalyst for modern computing machines. Notwithstanding the contributions by Al-Khwarizmi and other earlier mathematicians, Alan Turing was central in galvanizing theoretical aspects and its realization. In the first footprints of time, mathematics revolved around the domain of the initiated. Now, humankind is witnessing it is at the forefront of modern technologies. Fast forward to the 1980s, upon widespread adoption of computers and automation during the third industrial revolution, the fourth industrial revolution emerged between 2000 and 2010 with smart and autonomous systems fueled by data and artificial intelligence. As opined by many, mathematics is the queen of the sciences and number theory is the queen of mathematics. So, where once the queen of mathematics was kept serene and awed by many, it is now consumed by masses yearning for security in the cyber realm. Such is the story and future of the evolution of the sciences, specifically mathematics, hand in hand with nation building. Agak panjang lah karangan perenggan ni. Namun yang nak disampaikan adalah bahawasanya dengan penemuan oleh Alan Turing ketika beliau memberi nyawa ataupun kehidupan kepada hasil matematik beliau, sekarang sebenarnya semua ahli sains, terutama ahli matematik, berpeluang untuk terlibat dalam pembangunan negara. Okay. Caveat, this talk contains observations between 99 and 2024. It may contain weaknesses. You can comment, nanti, or you can send me an email. So a caution, the slide touch on research, development, commercialization, and innovation. It is as though it is everywhere, so you need to sort it out yourselves. Okay, so this talk has 2 parts, and I will inform when I stop, when I want to continue to the second part. And naturally, this talk is heavily skewed towards mathematics, but if you are from another field attending this talk, you can have a parallel universe experience by substituting the term mathematics with your preferred field during the talk. It will still make sense. Okay, now I believe most of you are academic staff, so I would take this opportunity to actually talk about how the ecosystem in the university, or at least in Malaysia, how do we contribute towards nation building. So everybody, most of you might know the term MYRA. It is the Malaysia Research Assessment, and MYRA has a lot of branches to it, and one of it is innovation. And innovation is the direction where you actually participate hands-on, direct towards nation building. Okay, so innovation is the place where you have the interaction with the outside community of your comfort academia zone. And actually, this is reflected in your yearly appraisal, especially UPM, maybe in other universities also. And innovation is part of how the ministry evaluates the performance of the university, and hence the university evaluates each of its staff. Right, there are 8, at least I know at the moment, there are 8 key performance index for research and innovation. Number 6 is intellectual property. Okay, the responsibilities of an academician. So as you might know, if you're from UPM, there are 4 main pillars that you have to participate in, right? Academic and internationalization, research and innovation, industrial and community relations, and also student affairs. So all these 4 pillars are important for you to participate and go the whole cycle, okay? Terlibat dalam keseluruhan ekosistem sebagai ahli akademik. Gunakan kesempatan itu untuk melibatkan diri dalam kesemua pillars untuk kita merasai keseluruhan ekosistem sebagai seorang ahli akademik. Terlibat, sudah pasti semua orang terlibat dengan undergrad dan postgrad. Namun terlibat juga dalam membangunkan silibus, membangunkan program baru, ini penting. Dan terlibat juga dalam mengusahakan recognition atau pengiktirafan antarabangsa. Untuk pendidikan inovasi, saya rasa secara umumnya ramai yang buat pendidikan dan juga buat grant, tetapi kena juga terlibat dalam menghasilkan harta intelek. Dan daripada harta intelek itu, kita perlu juga terlibat dalam pengkomersialan. Untuk jaringan industri dan masyarakat pula, kita mesti juga terlibat dalam urusan buat menghasilkan jaringan industri dan universiti, khususnya dalam bidang kita. Kita juga perlu terlibat sebagai subject matter expert kepada masyarakat di luar. Juga terlibat dengan usaha-usaha community dan juga menghasilkan income generation. Dia ada perbezaan antara income generation dengan juga commercialization. Commercialization artinya menjual barang. Maknanya kalau di universiti, barang yang kita jual itu harta intelek. Income generation tidak semestinya hanya menjual barang. Kita juga melalui consultation, melalui kursus-kursus yang kita lakukan. Dan untuk urusan hak ehwal pelajar juga, kita kena terlibat dalam pembangunan pelajar, welfare, advisory, student program dan sebagainya. Jadi kesemua ini perlu keterlibatan ahli akademik. Tidak ada pilihan sekiranya kita nak merasai keseluruhan ekosistem sebagai ahli akademik. And passion is the difference between having a job or having a career. So you need to ponder about this. Of course, kalau kita lihat 4 pilar ni, sempat kena buat semua. But again, if you are passionate about what you're doing, then that's the difference between a job and a career. So, okay, mathematics plays an important role in life. So someone must have told you mathematics is important, mathematics is everywhere. Everyone needs mathematics. The world can't survive without mathematics. If you are capable in mathematics, you can do well in other subjects. Really? Betul ke? Betul ke yang kalau kita hebat dalam matematik, kita akan boleh hebat dengan subjek lain? Adakah betul semua orang memerlukan matematik? Adakah betul matematik itu di mana-mana saja? Betul ke? Sebagai ahli matematik, jawapannya ya. Tapi kalau saya ada sesi dengan ahli matematik, saya boleh bertanya dan akhirnya jawapannya hanyalah pada domain matematik itu sahaja. Jadi kat mana sebenarnya urusan ini melibatkan masyarakat? Tapi untuk itu kita kena set the paradigm first. Ini satu masalah di kalangan ahli matematik, ini masalah yang paling besar. Kerana matematik is not just arithmetic, it is about patterns and relationships, it's problem solving, problem posing, and a way of thinking. Okay, the way of thinking, a tool of thinking, yang itu yang sebenarnya perkara yang perlu diambil cakna dari bagaimana kita keterlibatan dalam masyarakat, a way of thinking. Sebenarnya mathematician is an artist, right? Creates a masterpiece, sometimes not understood, most of the time misunderstood. But when it is interpreted correctly by other branches, the art is now science. So this is mathematics. Okay, so we need to be interpreted correctly by other branches of science, literally. So if you want to have a better overview, okay, this book is a must read. Semua kena baca buku ni. Mantik dan etnomantik. Walaupun saya struggle nak habis, tapi slowly habis. Is really thick, sangat tebal, mantik dan etnomantik. Dan daripada buku ni, kita sebenarnya dapat satu ilham bagaimana jati diri satu-satu bangsa itu keterlibatannya dengan matematik. Bagaimana matematik itu subur dalam satu-satu masyarakat. Daripada situ, baru kita boleh lihat balik ke dalam kepada kita dan kawan-kawan kita. Dekat mana sebenarnya the ticking point ni macam mana? Benda what ticks you? Apa yang what turns you on? Okay, what turns you on? Okay. So in a sense we need to actually focus on that direction. Okay, focus on that strength, and from that strength you can actually grow your field and so on and so forth. Okay, of course the common way of thinking, I mean the scientific way of thinking is mathematics is the language that connects physical sciences and metaphysics. So as a simple example, I usually give this to the students. So metaphysics, an example is like, for example, is happiness. Happiness. So katakan, for example, you want to buy a phone. The phone costs you 99 ringgit. You pay the shop 100. You get a balance of 1. So that's arithmetic. 100 minus 99 is equal to 1. So you use mathematics and you get happiness because you get the phone that you wanted to buy, right? But for higher level discussion, it involves philosophy and other stuff. So I leave it to the philosophers to discuss this. Now, one of the main reasons that hinders the progress in developing countries is that we are actually part of the, I would label it as an old school thinking. By a book by Mathematician's Apology by Hardy in 1940, he says, both Gauss and lesser mathematicians may be justified in rejoicing that there is one science which is number theory at any rate, and that their own, whose very remoteness from ordinary human activities should keep it gentle and clean. So he is propagating or advocating that mathematics, which is remote from human activities, is clean and gentle and is the purest of what a mind can develop. Or a mind develops the purest of your thinking, which is written down as mathematics. So this is excerpt from Hardy. Okay, this is what he thinks. In 81, another professor wrote, applied mathematics is bad mathematics. Okay, this is the way most of us are appreciating ourselves this manner. In a way that actually when we participate in something which is not specific in mathematics, then we are not contributing towards the mathematics sciences. So this is not something which is good for nation building actually. Yeah? It's not good. As you can see there, if you're not a professional mathematician, you may be astonished to learn that there are different kinds of mathematics, and there is anything in the subject for anyone to get excited about. Okay, there's a lot of mathematics actually. Okay, even if you go into the field of cryptography, one of the renowned professors, Koblitz, he also wrote a paper, The Uneasy Relationship Between Mathematics and Cryptography. It's as though as, for example, if I enter a discussion with cryptographers, the label would be, I'm a mathematician. But if I enter a discussion with mathematicians, I would be labeled something else. Okay, so this is what Koblitz has written in 2007. And since there is pure maths, another professor wrote about impure maths. You know, this is like, it's going nowhere. There's a pure math, there's an impure math. This is not good. This is not good for nation building. So usually we are talking about pure maths serves or feeds applied maths feeds mathematical application. So is this really true? Is this the way it's being observed, being practically conducted? Now, I will put forward the following relationship between fields and laboratories at a material science-based institute in UPM. So in this institute, the first lab does fundamentals of materials. So the lab scale design of new materials. Then it goes to the second lab, upscaling to prototype production. And then it goes to the third lab, manufacturing ready for mass scale industry. So this is at a material science institute, how the relationship between the three different pillars are conducted. Okay, so there is a really strong relationship between the three laboratories. So does it look familiar? Does it look like this? Okay, but is it true that a mathematician is trained in this framework, or is just material to mention applications during introduction of a journal article? Okay, so just think about this. Just think about this. So you need to put something, application, so you find out on the internet and you put it on your journal paper in your introduction or maybe in your summary. But do you actually engage in this whole ecosystem? So the concept of important. Gone are the days when something is important, when someone with a PhD says it is important. There is a new definition of important. Things that have no application / usage are not important. Okay, observe that I put the inverted commas on not important. Okay. To discuss content deep within one pillar is regarded as a waste. So this was the earlier pillars at the material science laboratory. So we need to ensure productivity is within this paradigm and ensure that it is seen as such. So for the next generation of mathematicians, you need to have this relationship between your fields. No longer that you can only just go deep into one pillar. It's wasteful. Of course, we can argue empirical evidence shows that mathematics is a field that needs hundreds of years before a real-life application can be found. This is the usual mathematician argument. So, for example, you have Al-Khwarizmi. So he wrote his algebra way back in the olden days. He was trying to solve Fara'id issues, which is the how you distribute the wealth after your parents' decease. Okay, but his mathematics is now used today by designers of the computer. Okay, what about Isaac Newton? When he first wrote his work back in the 17th century, he did not imagine that his mathematics would be used today by designers of space travel. What about Sanzi? 5th century. He investigated Diophantine equations, known for the Chinese remainder theorem. Certainly, he did not imagine that his mathematics would be today used by computer security. Okay, so 100 of years, now you have applications coming out. This is the normal argument. Within the modern context, these three mathematicians have played an immense role in nation building. The term nation building does not give justice. In fact, they built the world we live in today, the computer, going to space, cybersecurity. So, but moving forward, are we going to fit ourselves into this 100 of years paradigm? Or is there a need for us to actually work a little bit faster, connect with other fields, and so on? So what is the situation now? How do we inculcate mathematics in order to be integrated to the philosophy of nation building? Can mathematics actually play a role in Malaysia to give reason to nation existence? So if we go back in World War II, mathematics was actually really used effectively by the Allies to defeat the Axis powers. Okay. In fact, when the Axis powers, when the Nazis first invaded Europe, the first thing they did was they captured the mathematicians. Okay, they captured them. You can go to this website. I can share it later. And you can see a list of mathematicians that were captured or tortured, because it was a known fact that mathematicians gave the analytical soul to the society. So actually a mathematician is really important. But is that how mathematicians in Malaysia are playing their role? Okay, that's the question. Other examples, mathematics and World War II, you have this Professor Barclay. He was a logician. If you want to talk about pure of maths, this is the purest of the purest. But he was involved during World War II to ensure that his country won the war. Okay, the Enigma machine, I guess I will come back to this later. This is about encryption. It was also about mathematics. So that is in the past. Let's go to the future a little bit. Let's go to the United States of America. The top 10 best jobs are math related. How on earth a society or community of people in the United States puts mathematics as a really important field, and as such, it is one of the top. It is in the top 10 best jobs in America. All right. What does it mean? It means that if you're a mathematician, you'll get a job easily. That's how they appreciate it. Is that the case in Malaysia? Do we get to practice our mathematics in Malaysia? Here is a link, 85 things mathematicians have been hired to do in industry. 85 is compiled by the American Mathematical Society. One of the 85 is teaching, the other 84 is not about teaching. So it's something for you to think about. So maybe an academic from Department of Mathematics and Statistics, UPM, could compile such a list for Malaysia. Maybe we should populate a database. How many of our graduates actually, excluding teachers, others, do they participate in nation building doing mathematics? If we go to the States, the National Security Agency has a mathematical sabbatical program, National Security Agency. In IBM, they have a Department of Mathematical Sciences. In Microsoft, they also have mathematical department to do mathematics. Okay, let's move to the UK. Right? In the UK, there is an article, not an article, it's a government document. Okay, it's called The Era of Mathematics, an Independent Review of Knowledge Exchange in Mathematical Sciences. The forward is, the UK is an increasingly innovative economy, and the mathematical sciences play a key role both by providing solutions to numerous challenging problems and also by underpinning advances in other sciences the social sciences, and a wide range of key technologies. And recently, the UK is planning a National Academy for Mathematics, right? As you can see on the right, the Department for Science, Innovation and Technology wants the UK to become a maths superpower and take the lead in transformative technologies such as AI and quantum computing. The University of Lancaster received £12 million in investments for mathematics and artificial intelligence. So that's what's happening. This is what is currently going on in the UK. What about the EU, European Union? All right, another government document, Mathematics and Industry. You can see in the table of content, number 1, mathematics and its relationship with industry. Number 2, challenges and opportunities. 3, mathematics and industry, the missing strategic link. Number 4, recommendations, giving European mathematics and industry the edge. So I really propose that those attending, if you're interested, go and find this document and read it up. What about Japan? Japan. Another government document, the Ministry of Economy, Trade and Industry. The coming era of mathematical capitalism, how the power of mathematics changes our future. In the red box, note the term mathematics refers to mathematics in a broad sense, including pure mathematics. Okay, so this is how important mathematics is, and it is appreciated in the countries that I have given as examples. What about China? Huawei hires 700 PhD mathematicians, 700. And when they designed the 5G, it was all about mathematics. 5G was about the team of mathematicians in Huawei, which found the earlier work by a Turkish professor approximately 10 years earlier in the field of polar codes, and that mathematics was the source of the reason why the device is able to produce such speed, such as the 5G speed. The device was produced in Huawei. The mathematics was developed approximately 10 years ago by a Turkish professor. But the 700 mathematicians in Huawei knew what they wanted to search for. So probably the 700 could not derive the mathematics, but because they were mathematicians, they knew what to search for. And when they found the mathematics developed by the Turkish professor, then the equipment was given a new life, the 5G. In 2020, another article, Mathematics AI Perkasakan Status China, is talking about the crisis between China and America is now entering the phase, the ability to master mathematics. What does it mean? It means with the abundance of proven mathematical knowledge. As mathematicians, we know what proven means. It's not empirical evidence. Proven mathematical structures is only when you know how to give life to those mathematical structures, what the variables stand for. Okay, this is what is happening between the big superpowers. Which country has the best mathematicians being able to understand the mathematics and give life to the mathematics? So this is the way forward as a mathematician. What about Malaysia? Well, we have the Department of Stats, okay, but Department of Stats is not in our discussion. I would like to talk about cryptography. Okay, since this is my field of interest, let's talk about cryptography. So we need to talk, in general, not only in cryptography, in other fields also. We have to start thinking in the triple helix model of innovation. There is the university, there is the government, and there is the industry. Okay, new ideas, innovations is between the university industry, the government and industry has job, taxes and infrastructure, and the government university have funding and strategic demands. So this is how the triple helix, we should engage our day-to-day, how we produce our productivity. It should be within this triple helix model of innovation. So a little bit of cryptographic history in Malaysia. So the first Malaysian to obtain a PhD in number theory, which is the underlying of for cryptography, is in 85, which is an academic from UPM. And the first Malaysian to obtain a PhD in some form of mathematical cryptography was in 97, also an academic from UPM. Hence, the strong roots of cryptography in Malaysia is in UPM. Okay, so we have the roots of cryptography. I mean, this is history. Okay, right? We held conferences. Okay, number 3, 4, 5. Number 5 was the establishment of the society in 2007. All right, and we did more conferences, 6 and 7. And number 10, number 8, we set up a working group to pressure the government, and we drafted the national cryptography policy, and it was approved by the cabinet in 2013. So if you're really passionate about your field, you go at the highest level to make sure people understand your field, right? So in this case, we managed to get the policy, right? Yeah, and other stuff. There's a lot of history. Okay, and number 28, I submitted the paperwork, migrasi infrastruktur keselamatan maklumat Malaysia ke arah era komputer kuantum, which I submitted to the Prime Minister Office. I submitted a digital signature scheme to the NIST, June 23. Digital ID, Pfizer, this is the latest one, Pfizer Electronics, interest to collaborate with UPM. This is in January 2024. Okay, I will come back to this later. This is the society. Okay, if you're interested to become a member, you can go to the website. Okay, so you participate in the whole ecosystem. Okay, participate, example, doing policies, dasar kriptografi negara. All right, so when you participate in building national frameworks, you can pinpoint the pillars that you want. So for example, PF means plan strategic. So we embed research and development in cryptography. So from there, you get fundings to do the research, or you get more networking to do the research. And recently, in August 2023, we had a workshop to review back the policy. I was also part of the consultation team to develop the Malaysian Government Public Key Infrastructure Framework in 2016. Okay, I also was part of the Academy of Science 2018 team to produce this policy, cybersecurity, towards a safe and secure cyber environment. Also part of the MySeal, which is a Senarai Algoritma Cryptography Terpercaya, the list of trusted cryptography algorithms. Okay. Then there was the Malaysia Cyber Security Strategy 2020-2024. It was a huge budget, 1.8 billion. Okay, and so we had 5 pillars in the policy. So number 3 is catalyzing world-class innovation, and number 4 is enhancing capacity building and awareness and education. So number 3 and 4 are prospects. This is under the National Cybersecurity Agency, under the Majlis Keselamatan Negara. And we received this email in 2020, which they have identified UPM to spearhead cryptography in Malaysia. So you do your research, you do your networking, and then you move up the ladder. You have this MySty framework. If you're not aware about this, Malaysian Science, Technology, Innovation, Economy Framework, MySty 1010. This is how Malaysia is supposed to move forward. You know, these documents have a lot of words, but people actually really put effort into building these documents, and it's up to us, the people, the citizens, to move the documents. The documents, it's just a document. But if we don't refer to these documents and move in line with what is provided to us by people who have expertise in building such documents, so it's a waste. It's a waste. So this document, this framework provides a systematic approach to transform Malaysia into a knowledge-intensive economy by design. So not by accident, by design. It aims to generate shared economic prosperity across the diverse ecosystems in the country and shift Malaysia up the global innovation value chain. There are 10 science and technology drivers which was identified. So in my field, it's specifically there. Cybersecurity and encryption, and also blockchain. But other field of mathematics, I believe, can fit into any. And it's up to you to find which one is related to you. And these are the economic drivers: energy, business, financial, culture, arts, medical, healthcare. So we have this plot where we connect to each of the economic drivers and the science technology drivers. So this is how you should think. We should think of productivity in what we do. So we are participating in nation building by driving a particular economic segment. Okay, so UPM post-quantum cryptography research is empowering. MySty 1010. So cryptography is actually a science where the roots is mathematics, and you can have lots of applications such as e-voting, e-ticket, e-money, and so on. And it's not something that is something that you just can pick up easily. There are a lot of textbooks. This is the amount of textbooks that my students use. We have mathematical modeling for next generation cryptography, introduction to mathematical cryptography, cryptanalysis, RSA and its variants. There are a lot of books. Okay, I believe if you are here listening, then you have gone through these textbooks. And cryptology, which is divided into cryptography and cryptanalysis. If you do cryptography, it's design. It's like finding a needle in a haystack. Analysis is about finding flaws where you generalize. These are samples of research in UPM. I'll just briefly go through. This is with Dr. Amir Hamzah, a PhD student graduated in 2020. We attacked the RSA using arbitrary parameter. Okay, the aim is to factor n equals to PQ and to identify the number of parameters that fall within this category. So the work is basically, as a mathematician, we revisit old theorems or existing theorems. For example, we revisit Legendra's theorem, we revisit Coppersmith's approximation theorem, we revisit simultaneous Diophantine approximation theorem, we define according to what we have found, we put a remark, okay, just to make it more clear what we're defining. We build lemmas, we prove lemmas, lemma 1, lemma 2. Okay, the mathematician is having his joy right now. Okay, we are doing maths, we are having an hypothesis, we're looking at the outcome, we prove it. Okay, we build a theorem upon the lemmas. And finally, if you can see this theorem at the end there, then n can be factored in point of time. So that's the output. We prove, according to what we have found, we can factor the RSA modulus, which means the RSA is not secure based on our findings. Okay. Then, after we have proved the mathematics, we build algorithms. Basically, we just set out again the theorem, but in a more algorithmic way of reading it, so that the practitioners can go through the whole mathematics just by looking at the algorithm. So these are for engineers, for computer scientists who have other fields of expertise who do not prove mathematical structures. So they just go through the algorithm, and we provide examples of how the algorithm should work, and that's it. So it's the whole ecosystem, from literature review of existing theorems and definitions, axioms, whatever. Then you build you observe your own observations, right? You build your own definitions, then you build your theorems, your lemmas, your propositions. Then you put forward to the practitioners in an algorithmic way, and then you give them examples how to do it. So this is how the beginning, how a mathematician engages the society. Okay. Here is another theoretical work. We want to put forward to the community that our work is important. Why? Because our findings, we use asymptotic. It's like doing the prime number theorem, if you remember. We have an asymptotic approximation of how many numbers fall under our category. So we estimate the number of parameters that fall into our category. And again, we build lemmas, and finally we have a theorem, and the theorem says, as you can see there, n to the power 1/2 minus epsilon, which literally means there are a lot. Okay. So when there are a lot of parameters falling under our observation, it means that whatever we put forward, our findings, it means it is realistic, and it's important for users to take note in the event they might be using a weak RSA. Here is another work with my PhD student, Dr. Aklili, in 2021. From another angle, we study where RSA is insecure. Again, we put forward definitions based on our observations, right? We build theorems, we prove it, have a corollary, we put forward an algorithm for the non-mathematician to read and go through, right? We put examples for them to observe, and that's it. Another work with my master's student that just graduated in 2023. This is on post-quantum, where we found weaknesses on another type of mathematics, which is multivariate signature schemes. And the general aim is to make known multivariate distance 4G mechanisms and to lay out techniques to identify such mechanisms. So again, we define, okay, we build theorems, we build corollaries, we put forward our findings we discuss the findings, we put down the algorithm, okay, we discuss the complexity of our algorithms, we put forward examples for the user to go through. So basically, it's all about maths, okay? Okay, just to share, this is the number of graduates that I have right now, and I'm still having 7 students. So it's quite a big job doing this thing. So I hope my graduates, those who are already having PhD under my supervision, you can also take half of my students. Maybe later on, I will just give you a call and you can have my students. So it's, yeah, because you are well trained and you can also supervise PhD students. Anyway, another part of cryptography is designing. So this is designing for the country. This is in 2020, where, as you can see there, we designed an algorithm together with Dr. Ashraf and Zahari. This is in 2020. And this is the latest design where we submitted to the NIST for post-quantum digital signatures. Okay. So that's end of part 1. It's going to have another part 2. Okay, so if you have coffee by your side, then you can have your coffee. All right, next, moving forward, initiating Malaysia's transition towards the post-quantum era. So what is this post-quantum all about? So I would just like to mention that research is being done at the Institute for Mathematical Research at the Laboratory of Cryptography. So we do the whole spectrum from foundation research, which means mathematics. We do in system integration, prototyping, commercialization, industrial consultation, and designing of national policies. Okay, so this is the whole ecosystem that an academician should participate during your career. So why cryptography matters? It's because cryptography provides you these 4 things. First is about privacy and confidentiality. It's about ensuring that only your friends know what you and your friend want to keep secret. Authentication is to be able to know who sent you data. Integrity is to ensure data transmitted, it was not altered. And non-repudiation means a person that sent the data cannot deny sending the data. And if you look in history, cryptography was everywhere, Julius Caesar and whatnot. During the World War II, there was this machine, the Enigma, as I mentioned earlier. It used the Morse code to transmit ciphertext using the telegraph. So maybe you can Google what is a telegraph machine. Morse code is the dots and the dashes. And the telegraph is like the internet today. So whatever you transmit can actually be captured by a third party which you don't know who they are. So for example, in this case, the Allies intercepted the ciphertext, but they cannot read the ciphertext because it was encrypted by the Enigma machine. So the mathematicians they galvanized mathematicians and put them in Bletchley Park, and the task was to break the code. And the probability of success of breaking a code is 10 to the minus 20, which is very small. And furthermore, whatever mathematics that you do today or whatever work you do today, tomorrow doesn't mean anything because they change the keys. Okay. Furthermore, the combination is changed every day. To break the Enigma code is more than just guessing. It needed mathematical insights. So as a remark, advanced civilization, in this case, the British Empire, already has a high appreciation of mathematics, whether it's theoretical aspects or where to use it. And this capability is still here today. So this guy, Alan Turing, he derived some algebra, and to ensure that that algebra was able to work, because algebra is just pencil and paper, he had a insight that mathematics, because he was working on discrete maths, because he was intending to break the German codes, and the German codes were integers, so he was working on discrete maths. And he was able to see that every integer actually had its binary representation, the base 2 representation. Each integer written down in its symbolic form can be represented as a binary 2, and he had the idea that when the binary is 1, you turn on a current, and when the binary is 0, you turn off the current. Hence, you can have the whole set of integers represented by on and offs. So now, all he needed was to build a machine that could turn on and off very fast, put in his algebra, and that algebra, when you put in the German codes, you can read what the German intended to keep secret. So Churchill even referenced the Bletchley Park code breakers as his geese that laid the golden eggs but never cackled. And their work actually shortened the war by 2 years. So the algebra developed by Alan Turing was geniusly given life to electrical pulse. And they celebrated Alan Turing's 100th birthday in 2012. He died earlier, much earlier. And this is some of his handwriting. Okay, they auctioned it for 1 million many years ago. Somebody wanted to keep it. And there were movies on this. Okay, you can choose any platform to watch these movies. Okay, the issue is I'm producing this is that the timeline of the movies, 1996, 2001, 2011, 2014. So to produce movies on the same storyline shows the appreciation for complex entertainment and might be evidence on the level of scientific maturity a society has. Will you watch a movie that has the same storyline again and again and again? I'm not sure. Probably not. Yeah. And again, this is again and again the same story. It's a scientific movie, so-called scientific movie, but people still watch it. And I believe if there is in the year 2024, if they produce another movie about Alan Turing, people will still go and watch, at least in the UK. So it shows a level of scientific maturity. Do we have that? Okay, forward to 50s, 60s, 70s, there were lots of more computers, and to ensure the communication between the computers are getting secure, you need to have a sort of encryption, and the core of the encryption is to have the same key. So the keys are represented by numbers, and the crypto system is the mathematical how it's made secure, the information made secure. So you have the same key to encrypt and decrypt, okay, which is natural and it's easily understood. But it gave rise to a problem that never existed before, which is key distribution. So you need to distribute the keys. How on earth are you supposed to meet up with everybody if everybody has a computer? You cannot meet up with everybody to distribute keys. So mathematicians found a solution. All right. The solution is through the concept of public key crypto system, which is you encrypt using a public key and you decrypt using a private key. So it's like encrypting using key A but decrypting using key B. So you cannot open it up again using key A. So this concept was found in 1976 by these three people, Merker, Diff, and Hellman. They designed a secure key exchange in the beginning, and the source of security is known as the discrete log problem, which needs another platform to be discussed. But how secure is it? How secure is discrete log problem? I mean, as a mathematician, we would like to know. So they are mathematicians, and the analysis was mathematical. So given a number prime p, a primitive root a modulo p, and some b less than p, when you can compute the index of b modulo p with respect to a in expected time of exponential blah blah blah, which is sub-exponential. So meaning the complexity of solving the discrete log problem using the best algorithm known as index calculus needs sub-exponential time. Means you cannot find the answer. That's what it means. Okay, to discuss more, we need another session. So this algorithm is used, for example, here in Cisco routers. So the routers, to ensure there is a secure communication, they will do the key exchange. These are the famous cryptographers, Revesh, Shamil, Alderman. They established another algorithm called the RSA in 1977. Okay. And it's about the ability to factor the number n. You have two primes, p and q, you multiply them, you give the answer. Can you factor it back out? That's the question. And this is proven to be hard. Okay. So integer factorization problem, which is the source of security, given two primes, separate them. The product of two primes, separate them, factor them. So the complexity is given by this. The best asymptotic running time for the general number field sieve algorithm is sub-exponential. So there's a lot of mathematics until this complexity order was derived. So yeah, so a mathematician will provide you the answer. How secure is it? Is it difficult? So that's what a mathematician does. You design, you provide the answer to the security level and so on. So as a remark, determining hard problems is somewhat antithesis in conducting generalization. So finding a hard problem is not like doing generalization. A mathematician works generalizing things. So it's like finding a needle in a haystack. So which factorization is harder? Which is more efficient? Since it's a well-known fact that product of two primes is difficult, why not just multiply k primes, then you become more efficient. You become more secure. But is that needed? Is that really needed? Okay, is it efficient to do that? So you have to answer these questions mathematically. Okay, again, cryptology design is a needle and a haystack. Analysis is generalization. As you have seen in my earlier works with my students, when you do analysis, you do generalization. And then when there were new devices, small storage space, faster processors, resource-constrained device, meaning the batteries were getting smaller, the chips were getting smaller. We need better algorithms. So among them was the elliptic curve cryptography, developed by Koblitz in 85, and Van Stone actually commercialized it in 85 also, a company called Certicom. As you can see, the key size, if you use 512 RSA key, the equivalent strength is 112. So you have low bandwidth, meaning faster processing, you save the storage space and all this stuff. Okay, and this table was derived through mathematics. It's not just you just put the numbers just like that. This table is for the user, for the computer scientist, for the engineer, but the table was developed by mathematics, and these are empirical data that can be used by practitioners. Okay. This gave rise to another important question in mathematics, which is P equals or MP. Is it true or not? Okay, maybe some of you not aware of this question. It is one of the millennium problem posed by the Clay Mathematical Institute. Okay, it's about proving whether the set of questions or the set of problems which you can affirm the correctness and find the answer. Assume that you have a set a set of problems where you can affirm and find the answers quickly, okay? Just to put it layman. For example, x plus 4 is 5. So what is x? So you would do 5 minus 4, x is 1. So that means you are finding out the solution. So it's easy. 5 minus 4 is 1. If I give you x is equal to 2, and you do 2 plus 4, it's 6. 6 is not 5. So you are affirming x equals to 2 is not correct. But if I give you x equals to 1, you do 1 plus 4 is 5. So you affirm that it's correct. So these are the two items, finding the answer and affirming. Okay, there is a set of problems where you can affirm and find quickly. There is also another set of problems where you can affirm quickly, but finding out the answer it takes time. It takes a long time. So these two sets, the first set is what we call the P set. The second set is what we call the NP set. Are these two sets intersectional, or they are actually overlapping, or it's just intersection? So this is a question. There's no answer to it yet. And in this paper, it says if we can have an example of an asymmetric crypto system, as you can read that, this can never be the case for public key cryptography. Given a public key and sufficient time, an attacker can always deduce the corresponding private key and thus break the scheme. The best we could ever hope for is to show that an attacker is unlikely to break the scheme in a given period of time. Meaning, for any time, you still can't break it. Even with this more modest goal, the mathematics is unfavorable. A proof that there exists no strategy which would break a public key scheme with any reasonable probability would answer a famous open problem in theoretical computer science, which is also a field of maths. The NP not equal to B conjecture, for which the Clay Mathematical Institute has offered a 1 million prize. So the Millennium problem was posed many years ago. This paper cited it. This paper was published in 2010. Okay. Maybe one of you can try to solve it. There's a lot of, there's another 6 or 5 problems to be solved. So the story so far, you have the problems here, integer factorization problem, discrete log problem, elliptic curve. You have the best known methods for solving. So as you can see here, sub-exponential, full exponential, meaning you can't solve them. So the security is secure. Okay. So example, RSA, Diffie-Hellman, and all this stuff. These are this example of algorithms which are secure until now. Now, enter the quantum computer, right? The quantum computer is a computer that does not work on electrical currents. It works on the piece of light. And that light, the name, we call it a photon. It's a scientific name, we call it a photon. Layman speaking, if you go to the beach, you can pick up a piece of sand. So now scientists or physicists can actually pick up a piece of light. And this piece of light, it can do computational exercises. It can do computation. So it's the next industrial revolution. So we have 4.0 now on the right. So the next revolution is quantum computing. So quantum computing is where you have qubits against the bits. Okay. So your classical bit is 0 and 1. Your qubit is 0 or 1 or 0 and 1 at the same time. You have three positions which you can actually have, right? And together with this professor's work in 1994, which can solve the discrete log problem and the integer factorization problem in polynomial time. So as a result, the RSA, the elliptic curve, will become dinosaurs and will no longer be secure. So example, your bank, CIMB, as you can see there, I've highlighted in blue. This is what is called a digital certificate. As you can see there on the top left, there is the written certificate. This certificate is embedded into CIMB online services. And the algorithm that they are using is the RSA, as you can see there. Maybank uses ECC, as you can see the elliptic curve. And it will no longer be secure. All online cryptographic systems we depend on will collapse. Banking, commerce, communication, all will collapse. And according to the timeline, which is approved by many of the scientists worldwide, it will be in 2030, which is 6 years to go. Okay. Even if we refer to Gartner, their paperwork in 2017, you can see the red arrow on the left, quantum computing, which is denoted by a yellow triangle. And if you go to the bottom, the legend, the yellow triangle is more than 10 years. So this paperwork was derived in 2017, means it's 2027, which is in line with the timeline that most physicists or most engineers believe a computer will emerge in its full strength in 2030. So, okay, this is the slides are to pitch the government. You need to transition now. Why? Because there is a lot of devices connected and you just cannot have a short timeline to do the transition. Developed countries have seen this much earlier. In 2015, the total budget was 1.5 billion euros. This is in 2015. In 2023, the total global budget was 38.6 billion. As you can see, Malaysia has spent how many? Maybe RM1. No, it's not there. Not even RM1. So Malaysia hasn't spent anything. Thailand has spent 6 million, Singapore, and so on and so forth, as you can see. So why? Because the academicians stay in their cocoon. We are not advising. We need to go out and advise. Do you really believe the president of America knows about quantum computing? I guess not. But the scientists advise, go out, knock on the doors, meet people, do networking, and this is how it's supposed to be done. The National Security Agency in 2015 already mentioned you need to transition to quantum resistant algorithm, as you can see there in the red circle. The European Telecommunications ETSI already had a white paper in 2015 about quantum cryptography and security. NIST, the National Institute of Standards and Technology, had a paper in 2016. And they had this call for algorithms, people submitting algorithms to replace the RSA analytic curve in order to be secure against the quantum computer. And this 7-year period was actually a global mathematical exercise to break submissions. So people submitted, and the whole cryptographic mathematical community who were interested to see the security of the submissions, they went on and tried to break the submissions. And finally, in 2022, NIST produced 4+4 candidates which are supposed to be secure against the quantum computer. The first 4 is supposed to be the top 4, and the second 4 is supposed to be the backup. But upon publishing these 8 algorithms, okay, a mathematician in 1 month was able to break one of the algorithms that was published. What does it mean? It means it's all up to the mathematician to be able to see whether the algorithm is secure or not, because it's really mathematical and complicated. So this is, I mean, at least in this field, this is how mathematics participates in nation building or even in global building in this sense. So the NIST was not satisfied that because of these issues and because also of other issues, they decided to call for another round of submissions. Another round of submissions. They wanted it to have shorter signatures and fast verification. And during this round, we submitted. So it means the global transition has not arrived at day 0 yet. And we submitted. There were 50 submissions. Only 40 made it into round 1. So round 0, there were 50, and then only 40 was accepted into the next round. Okay, so okay, this is our specification of our design. We have shorter keys, which is much more appreciated in terms of real world usage. But it's up to the community to evaluate. We're still undergoing evaluation. But if you make a to A, apple to apple comparison, for example, our key is 200 bits, 400 bits, and 596 bits. If you compare to those which are accepted, 36,000 bits, 10,000 bits, 398,000 bits, as you can see there in the slides. So this is the one of the key factors where we had a real good discussion with NIST where we had 45 email correspondence between them and us because they just wanted to facilitate us in submission. And this is from our website. We had 661 downloads from November 2020. Yeah, on November 23. I think now it's near to 1,000 maybe downloads. As you can see, people are downloading from the States, US, Singapore, France, UK, and so on. Amazon, Google are downloading it. And they are testing it to see whether it gives a good, it's practical or and things like that. I was invited to Oxford in last year, September 23. It's by invitation only, meant to bring together top researchers in the field of post-quantum cryptography, both from academia industry for a twofold goal. Okay, so that's me. I was giving a talk there, and we had good discussion with the Europeans and the others, the Chinese, Koreans, the Japanese, and this is participation on the global scale. Right, I've talked about this. So what else? Okay, if you go in the newspapers, you have data breaches in Malaysia happening. For example, in August 22, it's reported 3,600 breaches. What does it mean about breaches? Right, JPN data breach here, data breach there, data breach everywhere. You have you have your MySejahtera giving out incorrect responses. For example, saying that you have COVID, but actually you don't have, right? So we responded to these issues by writing newspapers. Okay, so as an academician, you need to participate in this also. Participate in writing in newspapers, telling them what's correct, what is wrong, and so on and so forth. This is me writing in the Utusan Malaysia, and this is in the Star. My friend is writing here in Berita Harian. So yeah, this is the issue, is the lack of cryptographic protocol. Okay. So it was not encrypted. That's the issue. So there are laws. So I'm also part of the to review the laws. Digital Signature Act 1997. This is about cryptography. There is a law mandating signatures. Okay, and the law says you need to use asymmetric crypto system. I mean, the term asymmetric crypto system gives you a mathematical vibe. You know. Wow, you know, there is a law having mathematical vibes. Yeah, that's something. So then you have a secure key pair. Now, certainly that's mathematics, but in a very legal way of saying things. You have Personal Data Protection Act 2010, also going to be reviewed soon. Okay, I'll go fast. We have this from the Jabatan Perdana Menteri, which is the Pekeliling Laksana Proses Keselamatan Berkriptografi. This is in 2015. It says you need to use cryptographic technology. You need to ensure security. It's written there, underlined in red. Yeah, there are things called product cryptography terpercaya, and it's mandatory to be used. Okay, I've gone through this. Okay, now the latest is about digital ID. So digital ID is a platform where you identify yourself to the services online. And I pitched, and alhamdulillah, the government is going to use post-quantum as its secure mechanism. Digital ID is actually to prove who you are online and in person. Yeah, and is to do that, you need to digitally sign, and that's the difference between digital signature and electronic signatures. And another term, which the correct term is called image of your signature. So you have an image of your signature, you scan it, and you have a PDF, you paste it, or a Word document, you paste. That is not a digital signature. That is an image of your signature. A digital signature is a mathematical structure where you sign using your private key and verify using your public key. This is what digital signature is. Okay, so hopefully after this talk, you know the difference between digital signature, electronic signatures, image of your signature. So these are different things. So you use digital signatures everywhere in the courts, healthcare, and so on in developed countries. We're hoping that Malaysia will also be going through this phase. Okay. The digital ID aspiration, as you can see, the ID aspiration, there is original solution, 100% local talent, engage local ecosystem, AI, and so on. But the in the middle, the solution will be design advanced security such as post-quantum computing cryptography, So this was the acceptance of an idea which I pitched to the government, where they will use post-quantum cryptography in Malaysia's digital ID. These are slides, as you can see there on the left, top left, mampan dan pertama di dunia menggunakan pasca quantum. On the right, akan direka bentuk dengan sistem keselamatan termaju seperti post quantum. Is there on the slide. So this is the way forward for digital ID. Okay. Okay, here the team where we finalized the discussion at MIMOS with our previous Deputy Vice Chancellor to develop the solution. I was also given the chance to explain to the Prime Minister what is post-quantum. This was November 21st last year. Okay, UPM has a non-disclosure agreement with Telecom. We will do R&D, commercialization, innovation with Telecom. Okay, this is me giving a talk to the government officers in September 2022. There were around 300 to 400 participants. So I advocated to them they need to change to post-quantum cryptography. The society also conducts workshops. Here is in February last year where we advised the minister on post-quantum cryptography. The minister at that time actually adopted it into the budget, but then there was a little bit of change and it didn't happen. This is the paperwork that we submitted to the minister, empowering Malaysia's digital infrastructure in the era of quantum computing. Okay, this is me giving a talk at Puspahanas, which is the training center for 2-star generals to before they become 3 or 4-star generals. So it had to, I was advocating to them the security of the country is also with relation to the cyber security, which is post-quantum secure. Okay, here is the paperwork I submitted to the Prime Minister. Tujuan kertas ini selaras dengan arahan Majlis Keselamatan Negara. Perdana Menteri merupakan pengurusan kuasa keselamatan cyber negara. Justru tujuan kertas ini adalah untuk membawa satu arahan kerja untuk pendekatan whole of nation approach. Okay, China and Russia and stuff. The White House is looking into this thing really seriously. They have already, in May 22, from the President himself to all the ministries, Secretary of State, Secretary of Treasury, Defense, General, Commerce, Energy, all the ministers are given a timeline of 12 to 24 months to migrate to post-quantum. So it is, as you can see there, the United States must pursue a whole of government and whole of society strategy to harness economic and scientific benefits. Okay. Within 1 year of this memorandum shall provide a guidance on quantum resistant cryptography migration implementation. So this is what Malaysia needs, and I'm still advocating for this work order, arahan kerja. And in the States, they already have a law. The law is called Quantum Computing Cybersecurity Preparedness Act. As you can see there, Section 1 is called Quantum Computing Cybersecurity Preparedness Act. So there is already a law for United States of America to change the cryptographic system into post-quantum cryptography. The French are using post-quantum cryptography for its messaging already. The Canadians, okay, they have research budget, as you can see there, 141 million. So a lot is going on all over the world. Okay, here are some companies using this. The total economic benefit globally, this was in 2019, is supposed they supposed it is as large as $3.9 billion by 2028. But when they reviewed back in 2023, the actual market should reach around 8.8 billion by 2030. So there's a lot of opportunity for Malaysians to participate. I hope there are innovators in the audience or computer scientists or engineers that can take up and do this. Okay, again, 16 agencies, 40 participants. This was in November, advocating again to change to post-quantum cryptography. We are working on the Malaysia Quantum Resilience Center. All right. Okay, patenting, okay, to mathematicians is a doable thing. You can do patenting because patenting is how you go out and participate in nation building, okay? So your patent maths is a process, okay? I can give a talk on this later, but basically to patent maths is just to patent the process on a hypothetical device, okay? So you have a device doing your maths according to a process and then your patents. Okay, as an example, here's a US patent by me is no patent to 2012. It can be done. So if I mean any person can derive a mathematical structure into a flowchart working on a hypothetical device. Yeah, that's what patent is all about. So if somebody actually develops that hypothetical device, then they owe you royalty. They have to pay you licensing fee for that, or you can also give them for free. It's up to you. Okay. All right. Why is important for commercialization? Certainly, you can have extra income, new job opportunities for people, and of course, UPN mission to make. This is the English translation of UPN mission to make meaningful contributions toward wealth creation, nation building, and universal human advancement through the exploration and dissemination of knowledge. So it's all about wealth creation to have people to have benefit from your research. Okay. So for example, if you do commercialization through the university will tax you, and that money will be used to pay somebody's salary. So that's how the ecosystem works. I did licensing with Telecom in 2014. Now I'm in talks again to license again with Telecom. Okay, I'm working with Telecom right now with Petronas, Phison. Okay, I'll go through very quickly. Here's a non-disclosure with Telecom. Okay, this is just recently in Singapore where I had the opportunity to network with the Ministry of Communication Indonesia, which they also wanted to do digital ID and they're interested in the post-quantum thing. So I told them, if you're interested, you can come over to Malaysia and we can talk. So with Petronas, we had a meeting in January also, and they were interested. Okay, maybe next slide. Here with Phison. Phison is a company which does controllers. It's a 2.04 billion companies. It does controllers, and there are controllers part of the chipset, and it's used to go to the moon and go to Mars. So you can see that the red box there. In the middle, there's a picture of a integrated circuit. In the red, this is what we call a controller. In there, that's where the cryptography is put. So yeah, you can go to the moon and go to Mars and things like that. Yeah, this is communication with the owner of Phison. He gave me a message. As you can see there, I can offer you PM all technology and bring back Malaysia on track. Actually, Dato Puah is a Malaysian, and he was the designer of the thumb drive. Dato Puah is the designer of the thumb drive, and from modest beginnings in the year 2000, from the thumb drive, he is now designing for Tesla, he's designing for NASA, and that's how he's now he wants to go post-quantum secure for his chips, and we are in discussion on how to do this. So it's an opportunity for income generation. It's an economic driver for the future. Yeah, digital ID, telecom, as I mentioned, Petronas. So what is the direction with Petronas? The direction with Petronas is that we will secure the IoT on the oil rigs. So as you can read there, cryptographically secure, integrity preserve IoT data transmission of foreign unwanted content mixed with raw petroleum or gas and cryptographically authenticated data access of such data. So it's a long sentence. Phison, again, as I mentioned, is about the controller. In the controller, we'll be talking about post-quantum integrated circuit. So they are offering to build a post-quantum design center in UPM. So yesterday I was also in discussion. They're really interested, and let's see how it goes. Okay, secure hardware. So we're talking about electronic cars, video surveillance, drones, and so whatnot. And the mathematics will be in there, part of it. Okay, aerospace, transportation, medical, data age, and stuff like that. So this, the direction, I mean, once you go through the process, our aim is for nation building. And in this case, we need to take Malaysia out from the middle income trap. It has been a long time since Malaysia has actually become a country which the graduates, the professionals have a high salary. And this is because of what we know as the middle income trap. So this middle income trap can only be overcome if the productivity rate of Malaysia is really, really high. And to get a high productivity rate, every person in Malaysia, including academicians, including mathematicians, have to engage the economic sectors. Otherwise, we will still be there in this economic trap, middle income trap. Other places where we can use application is in the military applications, IoTs. Okay, so I meant coming to the end of the talk, 1 hour and a half. So mathematical scientists, identify your enabler field. Computer science, engineering, economics, big data, AI, etc. Find out. Go to other faculties, go to the computer science, go to engineering, go to economics. Engage, do connect, do networking, right? Be meaningful. Take the lead, be innovators, contribute to nation building. Be the guy in yellow, not the guys in blue. Be the vector in red, not the vectors in blue. Do research, development, commercialization, and innovation, the whole ecosystem. Do everything while you are still in service. Be innovators, be the top 2.5%, not early adopters, not early majority, not laggards, certainly not laggards. So what's next? Okay, in the Department of Maths, we have these 4 new directions, which is good way forward. We have the Bachelor of Mathematics option, scholarship option, Applied Mathematics, Industrial Statistics, Business Management, and Cryptology and Computer Data Security. And with this new program where the final year students are now in their, I think, 6th semester, the first batch, the country is awaiting. Actually, in most of my meetings, I have been advocating that UPM is the first in the country to produce mathematicians with cryptographic and data security background, and they are waiting for our first batch. So hopefully, it will be meaningful for the country. So it's a quite exciting future to go where no one has gone before. So finally, as such, every citizen has a role to realize the potential of the nation, to bring Malaysia a step closer to realize Malaysia's Vision's 2026 challenge, establish a scientific and progressive society, a society that is innovative and forward-looking, one that is not only a consumer of technology, but also a contributor to the scientific and technological civilization of the future. So it does not matter where you become directly involved in maths or just become a user of maths. It's the underlying concept that needs to be embodied within each action for agama, bangsa dan negara. So that's how I view the issue. Okay, be innovators. Okay, this slide is when I pitch the government. So saya telah sampaikan kepada pentadbiran, jadi kena laksanakan kerja. Dan surah Al-Anfal, sediakanlah untuk menentang mereka musuh yang menceroboh segala jenis kekuatan yang dapat kamu sediakan. So specifically in cryptography, this is what we do. We combine our intellectual, harness our intellectuality to ensure that we are secure. Our information security infrastructure is secure. Thank you. I hope that was interesting.
Okay, terima kasih Prof. Dr. Rezal Muhammad Rezal. Memang sangat menarik dan juga banyak maklumat dan peluang ya yang ada untuk pendidik sekarang ini untuk mengambil bahagian dalam aktivitis kriptografi dan juga mungkin dalam bidang-bidang matematik yang lain ya, Prof. Dr. Rezal.
Ya betul, sebenarnya banyak sangat, terlampau banyak.
Okay, saya buka, Zurita boleh buka untuk soalan?
Boleh Prof.
Ya, dekat pukul 12. Alright, saya buka untuk soalan? Ada yang ingin menanyakan sesuatu daripada Dr. Rezal? Banyak experience Dr. Rezal.
Saya rasa salah satu benda, one of the things that you can do actually is go back to the the literatures. I mean, every field in maths has its originating literature, and you just have to find out. And from there, you can engage the participation. You can engage the participating field of science. So example katakan OR, operating research, and is related to military, right?
Yeah, is
So yeah. So then just go and
related to real world problems lah.
correct.
Right.
Statistics, AI, all this
Yes.
stuff. Yeah.
So I guess you have to be more proactive lah ya. Yang lain tu macam statistik can be in biology,
Yep.
medicine and so on. So we have to really main peranan kita sendirilah. Don't have to wait.
And then you gather around like 10. Not only mathematicians, you gather from other fields also around 10, and then work on a draft of a policy, push to the relevant ministry, and then you get your budget from the policy. It can be done.
Yeah. So collaboration, di antara all the bidang yang ada ya. Sebab you said just now is mathematics is everywhere, right?
Betul.
Okay, ada soalan? Kalau kalau you have a question, maybe you can menghubungi Dr. Rezal sendiri ya.
Saya ada soalan boleh?
Okay, go ahead Amir.
Okay.
Okay, first of all, saya nak tanyalah, selain daripada kriptografi, apakah area of mathematics yang Prof nampak ada potential untuk dibuat similar to what you have done in cryptography in Malaysia?
Okay.
Another area of mathematics. Yeah.
I think the nearest ialah okay, of course dia bunyinya macam apa cringe lah, macam cakap okay semua dah cakap pun it's AI and statistics. I mean, but actually the way that data is being treated in Malaysia, I think it can be better with a statistician yang ada the correct knowledge. The way you move forward is again to engage dengan practitioners, kemudian draft a policy for correct AI management. Example, correct big Malaysia, correct managing of Malaysia big data infrastructure, something like that. Just put us, and then inside there tulislah semua statistik yang sepatutnya dibuat. That okay, statistic, that's one. Okay,
maybe we can relate it to padu.
Boleh juga. But then again, jangan lambakkan terlampau banyak benda-benda cadangan. You just do one. So maknanya katalah ada statistician yang tidak terlibat dengan dia bukan tidak terlibat, mungkin sebab dia punya bidang tu they might feel uneasy to participate or whatnot. But then again, just rope them in. Once you go and meet people, you do networking, it becomes more interesting. Orang yang mula-mula macam nak tak nak tu, akhirnya dia pun akan minat juga. When you go and meet people, everything becomes more interesting rather than just sitting down. Okay, statistics is like that. Okay, kalau mathematics, there is a new policy, nama dia let me nama dia kejap NMIP, lupalah apa maksud dia. It's about the national policy on microprocessors, integrated circuits, benda-benda macam tu. There's a new one. Later kalau saya jumpa saya akan beritahu. It's about this. So dekat situ lagi banyak. There's optimization. Certainly circuits, there is differential equations and all this stuff. So dekat situ mathematician boleh participate. You can derive a policy on how to design nationally endorsed integrated circuits, because kat Malaysia belum ada lagi tau integrated circuit manufacturer yang full blast. That is one. So I think integrated circuits dengan mathematics, every field of maths can do. Maknanya tak perlu, I mean, you have your graph theorist, you have your whatever, everybody can participate, even though it's like a low level, it's a low level, what I'm trying to say, it's a low hanging fruit, benda yang sangat mudah untuk semua orang terlibat. So let's just take up these two challenges for the next 5 years. Let's see whether, because it takes a long time, nak buat polisi kriptografi pun hari tu pun 3-4 tahun juga. So take up these two challenges, or maybe you have your own ideas. Number one is the correct way of interpreting data on Malaysia big data ecosystem, and number two is about the Malaysia integrated circuit punya new policy. So how to design correctly, and then you have your own sciences of designing using the correct mathematics. Sebab certainly design of integrated circuit adalah mathematics. Tu sebab bila saya bercakap dengan Faisal, they are really interested because they know that the baseline is maths. So these two lah, yang lain-lain tu banyak lagi, tapi kalau nak buat boleh lah, tapi lebih baik consolidate all the strength into few things and do it first. Itulah yang saya rasa.
Okay, Amir.
Thank you, Prof. Thank you.
Ya, alright, disebabkan kekangan masa ya. Terima kasih banyak-banyak Dr. Rezal. Mungkin next time around maybe you can talk on the other things that you have mentioned just now.
Okay.
Right.
Tahun depan.
Terima kasih banyak-banyak. Ya, tahun depan pula. Okay, saya serahkan kembali kepada Puan Zurita.
Terima kasih Prof. Nur Akmal dan juga Prof. Dr. Muhammad Rezal atas perkongsian way forward mathematics di Malaysia dan juga di peringkat global, juga kepentingan dan keterlihatan matematik di peringkat antarabangsa lah. Bagaimana kepentingan matematik itu sendiri memberi kesan yang amat signifikan dengan kita punya kehidupan semasa. So sebelum kita tamatkan ceramah kita pada hari ini, saya ingin mohon untuk peserta untuk membuka kamera sekiranya boleh untuk sesi bergambar.
Oh, khabar Prof Jumat.
Baik, terima kasih. So,
Alhamdulillah.
Prof Aismm.
Ya, saya kat rumah je lah. Prof Zanaria, khabar. Dr. Nizam. Baik. Okay, yang lain? Tak nak on
Yang
the
lain
camera?
Okay, okay, 1, 2, 3. Okay, sekali lagi. 1, 2, 3. Okay.
Okay.
Terima kasih Prof.
Okay,
Terima kasih
kasih
Prof.
semua.
Terima kasih semua.
Ya.
Terima kasih.
Right.
Saya run SFB kan, tanya lagi. Ya,